So we're going to look at the last lesson in this unit, which is 8-4. It's on geometric series. So the sum of the terms in a geometric sequence is known as a geometric series. And so you see here the series 2.5 plus 5 plus 10 plus 20 plus 40, that corresponds to the same sequence just with commas. So the only difference really between a sequence and a series is a sequence has commas and a series has addition or subtraction signs. So the sum of this particular series, if you just add them together, is 77.5. In infinite series such as this, so you've got first term, second term, however many terms so you get the last term, and then if you have a dot, dot, dot at the end, is said to converge, and we'll talk more about convergence versus divergence later, is said to converge if the sum gets closer and closer to a real number as you increase in the position number of this in the sequence. So for instance, what if we had the following series? 1 plus a half plus 1/4 plus 1/8 plus dot, dot, dot. And so as you look at this, to go from 1 to 1/2, from 1/2 to 1/4, 1/4 to 1/8, we must have multiplied by 1/2. So our R is equal to a half, and so the series is going to converge. If you actually start to add this together, if you add these together, it's getting closer and closer to 0, because every time you have something, like the next one's going to be 1/16, the next one 1/32, the next one 1/64. So each of these numbers is getting closer and closer to 0, but because we started off with a first term of 1, if you start to add these together, you will see that our sum is going to get closer and closer. So the series converges, meaning getting closer to, converges, that's an ER, to 2. So it converges to the number 2. In infinite series, we'll diverge if it does not converge. In other words, that is really a horrible, see, if you could see how I have to write on this, you would understand why my handwriting looks terrible. So diverge, that looks much better. So basically, if a series is diverging, it is not getting closer and closer to a particular number. The numbers are getting bigger and bigger and bigger and bigger, or smaller and smaller and smaller. In other words, they're approaching positive infinity or they're approaching negative infinity. So for instance, an example of a divergent series might look like, we'll start with 1 again, but maybe our R this time is 2. So if I double every time, I'm going to get 2 plus 4 plus 8 plus 16 plus dot, dot, dot. So you can see that the number is getting bigger and bigger and bigger. And so it diverges because that R is equal to 2. So I cannot actually add this up and come close to a number, because this is going to add up to infinity. It's not going to actually add up to a specific number. Whereas this is going to go on infinitely, but it is going to add up to and approach the number 2. So there are some formulas that you do need to know. And so I would highly suggest that you know the sum of a finite geometric sequence, and so this is going to be important. And then I don't like the alternate form right here, so if I were you, I would just put an X through that one. I would just learn one of the two. If you want to learn both of them, be my guest. But you're going to use this one if you have a finite sequence, meaning you can count the number of terms. So n would be the number of terms. A sub 1, of course, is your first term. R in both of these cases is going to be your ratio, and n again is the number of terms that you're adding together. please make sure that you put parentheses around your r, especially if r is negative. Then for the sum of an infinite geometric series, you're going to use this formula right here. It's a much simpler formula. You only need a sub 1 divided by 1 minus r, and this works 100% of the time as long as, and this is the key point, your ratio is less than 1. The only way that you have a converging infinite series is if your ratio is less than 1. So it has to be, 1/2, 2/3, 5/6, anything less than 1, and it's absolute value-wise. As soon as that number becomes bigger than 1, 2, 1.5, 1.3, 1.1, it is going to diverge, and you will not be able to get a sum because that sequence will just get bigger and bigger and bigger. So make sure you pay attention to what your ratio is. And then note here, an infinite geometric series with a ratio that's greater than or equal to 1 does not have a finite sum. So that's what I'm trying to get across to you. This series is said to diverge. So look at example 1. What do you need to find the sum of the first 8 terms in this series? Now you have the first 4. You could use recursion and find the next 4 and just add them together. Or you could go ahead and use this formula right here. We would use this one up here because we have 8 terms. It's a finite sequence. Even though you're looking at it here and it's infinite, we're only adding the first 8 terms. So the things that you need would be a sub 1. So we have that, which is 3. And you need your common ratio, which we can figure out from here. So I don't need to know my common rule. So my r is 2 because we were multiplying by 2 every time to get the next term. And then my a sub 1 is 3 because that's my first term. So the more times that you write down your formula, the more likely you are to learn it. So we're going to use this formula. And so I'm going to do the sum of 8 terms. And so my first term is 3. And my common ratio is 2 to the 8th. And then divided by 1 minus 2. All right, if you throw that in the calculator, you will get 765. All right, so then let's look at the next example. And so in example 2, you are to find the sum of the finite, so we're using that first formula, geometric series. The problem is I don't know in this case how many terms I have. I don't know what position in the sequence this particular term is. So that's one thing that I'm going to have to find. The things that I do know are a sub 1 is 3. And then as I go from 3 to 6 to 12 to 24, I know I'm multiplying by 2. So my r is 2. And then my n, I don't know. That we're going to have to find out. So let's start with number 1. We're going to find n. So I'm going to have to find my common rule. So this is a geometric series. So I'm going to use my rule, my explicit rule for a geometric sequence, which looks like this. It is going to involve some logs. So I'm going to plug in the values I know. I know that my last term is 1536 equals, I know my first term is 3 times, I know my ratio is 2, and it's the n minus 1. So then you want to divide both sides by 3 to get the power by itself. And so 1536 divided by 3 is 512 equals 2 to the n minus 1. So now because my variable is in the exponent, I have to use logs. So I'm going to go to log form. So I'm going to convert this from exponential to log form. So I'm going to have the log base 2 of 512 is equal to n minus 1. And so I'm going to use the change of base formula. So log of 512 over the log of 2. And I want to add 1 in order to solve for n, because here, of course, I would add 1 to both sides. And so I am going to get 10. So n will end up equaling 10. So now I know that n is 10. So then step 2, I can just plug into the formula. So my sum of 10 terms is equal to, my first term is 3 times 1 minus, and then my r is 2 raised to the 10th power, all divided by 1 minus 2. So s sub 10 is going to equal 3069. All right, look at example part B. So here we have 15 through 480. Now technically you could just take this plus this minus this plus this minus this plus this, and you could just get an answer. Or you can do it algebraically. I know that this is term 1, 2, 3, 4, 5, and 6. So I know that I have n is 6, a sub 1 is equal to negative 15, and r is, since I'm waffling back and forth between a positive and a negative, I know that r is a negative 2. So when I use my formula, I'm going to have s sub 6 is equal to negative 15 times 1 minus, and I'm going to put this in parentheses because my r is negative, and that's going to be raised to the 6th power, all divided by 1 minus negative 2. And so when you throw that in your calculator, s sub 6 should turn out to be, let's see, all right, so 1 minus a negative 2 to the 6th is equal to negative 63, and then divided by positive 3. It's negative 21 times negative 15 is 315. All right, example 3, part A. So this time we are to find the sum of the finite geometric series. So again, it's just in a different notation. It's in sigma notation. Remember, this notation means to add. So our lower bound is 1 and our upper bound is 10. So we have 1 to 10, that's 10 terms total. 10 minus 1 is 9, plus 1 is 10. Our first term is a sub 1. This is our r, and this only occurs when n is 1, and this is n minus 1. So otherwise you cannot assume that that's your first term. All right, so because it's in our standard form, I know that a sub 1 is the 5. I know that the r is the negative 2, and I know that n is going to be 10. So s sub 10 is equal to 5 times 1 minus, and then in parentheses, negative 2 raised to the 10th, all divided by 1 minus negative 2. So then, all right, so then I have 1 minus negative 2 raised to the 10th So that's negative 1,023 divided by 3 is negative 341 times 5. So S sub 10 is equal to negative 1,705. All right, part B. So part B, I'm going to let you do it on your own, but you've got to be a little careful because your lower bound starts at 0 and your upper bound is 24, and this is not n minus 1. So to get your number of terms, you have to do 24 minus 0 is 24, and then plus 1. There are really 25 terms here. So to get your a sub 1, you have to plug into the formula your lower bound, which is 0. So your a sub 1 does indeed turn out to be 3. And then you can always assume that that thing in front is your first term. And then your r is the 1/2. And then your n, as I said before, is 24 minus 0 plus 1, which is 25. So the sum of 25 terms is equal to 3 times 1 minus 1/2 raised to the 25, all divided by 1 minus 1/2. All right, so that equals, so survey says, all right, so I'm going to take 1 minus 1/2 raised to the 25 divided by 1/2 and then times 3. So I get 5.9999999. Well, that's pretty darn close to 6. It rounds up to 6. So S sub 25 is approximately equal to 6. All right, so then we have a word problem on our next page. And the word problem says, it's as big as I can make it, I apologize. So you make a contract with your parents to do work 8 hours every day during the month of July. The first day, you will be paid 1 penny. The second day, 2 pennies. On the third day, you get 4 pennies. The fourth day, 8 pennies, and so on. Is this a good plan for you, or do your parents get the most out of the contract? So let's go ahead and set up the sequence. So on day 1, you're getting 1 penny. Day 2 is 2, 4, 8, and so forth. So this is a geometric sequence because your R is 2. You are doubling every day. And your a sub 1 is 1. And it is an infinite series, of course, because, well, technically it's not infinite. I mean, it could be infinite, but they're cutting it off after, where is it? During the month of July. So how many days are there in the month of July? So your n is going to be 31 days. There are 31 days in July, in case you didn't know it. Shocking that you didn't know that. All right, so then it's turned into a finite sequence because it's 31 days in July. So we're going to find S of 31. And mind you, our answer is going to come out in pennies, so we'll convert it to dollars and cents as well. And that equals 1 times 1 minus 2 raised to the 31, all divided by 1 minus 2. Okay, so if I do 1 minus 2 raised to the 31, I get negative 2,147,483,647. I'm going to divide that by negative 1, which gives me the positive of that, and multiply it by 1. I have quite a few pennies. So S sub 31 is 2,147,000,000. Did I say million before? 2,147,000,000, such a big number, 483,647. Now, for every 100 pennies, that's $1. So I'm going to divide this by 100, which really just moves a decimal point. And so that equals 21,474,836.47. What do you think? You going to try to propose that to your parents? I'm guessing that you get the better deal. So this is a great, whoops, if I can spell, I'm so excited over that money. This is a great deal for you. Good luck getting your parents to take this deal. They'll figure it out after a couple of days because the doubling occurs so rapidly since it's exponential growth. All right, so then look at example 6. This one says write the summation notation and find the sum of the first 6 terms of the geometric series. So I'll pause and let you, well, you pause and you figure out the answer to this, and then you can check your answer. So I'm going to write the summation notation. So I'm going to make the assumption that we're going to start at 1 and we're going to go to 6 terms. So our upper bound is going to be 6. I am going to have to find the rule. It's not that difficult because I know that my first term is 3 and it's geometric. So I'm multiplying by 3 every time. Am I? No, 5. Multiplying by 5 every time. And so my R is 5 and it's to the n minus 1. So we're going to find our sum of the first terms. All I need is a sub 1, which we already know is 3. Our R is 5, and that's it. So S sub 6, or N, well, we kind of already knew that, so our N is 6. Our S sub 6 is equal to 3 times 1 minus 5 raised to the 6th divided by 1 minus 5. All right. Let's find that one. So we've got 1 minus 5 to the 6th. That gives you negative 15,624. Divide that by negative 4. 3,906, and times 3 is 11,718. All right, so for example 7, you are to again write the summation notation and find the sum of the first 10 terms. So again, I'm going to pause. You're going to write the notation and find it and then check your answer. So sigma notation, n is going to equal 1. And then as we go from our first term to our second term, it got cut in half and got a negative. So it looks like we're multiplying by a half and it's a negative half. Same thing here, that's multiplying by a half, multiplying by a half. So our R is negative 1/2. Be careful with that, make sure it's always in parentheses. We're going to do 10 terms, so we're going to go to the 10th in our upper bound. Hey. So the first term is 2 times your R, which is negative 1/2, raised to the n minus 1. And so I need a sub 1 is 2 and n is 10. So S sub 10 is equal to 2 times 1 minus negative 1/2 raised to the 10, all divided by 1 minus negative 1/2. There we go. All right, so if I throw all of that into my formula and with my calculator, you're going to end up getting a fun fraction, 341 over 256. All right, example 8. Question says, determine whether the series converges or diverges. So it converges if your R is less than 1, diverges if your R is greater than 1. So as we look at this, we go from 1/2 to 3/4 to 9/8. It's kind of hard to tell. So the best way to tell what your R is, if you recall, is to take the previous term. So I'm going to take 3/4 and I'm going to divide it by the term in front. So previous term divided by this term, or 9/8 divided by this term. I just chose these two because they're smaller numbers. And so remember, you're going to keep, change, flip. So keep the 3/4, change division to multiplication, and flip your denominator. 2 goes into 4 twice, and so you end up with 3/2. Well, 3/2 is greater than 1, so since R is greater than 1, the series diverges. So that means that there is no sum. No sum. Oops, that's a crazy M. No sum. All right, last page of notes. So again, you're just trying to determine, does the series converge or diverge? So again, you have to find your R. So I'm going to let you pause and you figure out what the R is and go from there. So again, if you want to figure out what your R is for sure, you could kind of tell it right here. Number 1, it's waffling back and forth. So I know it's negative, so I'm going to ignore the negative for right now. And you can see that the denominator is being multiplied by 3, so it is 1/3, but I'm going to prove it to you. I'm going to take 1/9 and divide it by 1/3. So keep the 1/9, change to multiplication, and flip. And then you end up with 1/3. So your R is actually negative 1/3, but it doesn't matter. You look at the absolute value. Since R is less than 1, absolute value of R is less than 1, these series converges. So there is a sum, and so it's very easy to find. So let me move this over a smidge so I have a little bit of room. And so all we need is a sub 1, which we have a sub 1 is equal to positive 1/3. Just making sure it wasn't negative. And then our R, as we stated earlier, is the negative 1/3. So it's a little confusing because they're both the same number, but you're using a different formula. So we're using the sum is equal to a sub 1 over 1 minus R. So my a sub 1 is 1/3 over 1 minus a negative 1/3. So that becomes a positive, and we get 1/3 divided by 4/3. And so I'm going to keep change flip, so 1/3 times 3/4. These are going to cancel, and you end up with a sum of 1/4. And it's nope, it's positive 1/4. Yep, positive 1/4. Just double checking. All right, so then last problem. If the series converges, can you use a calculator to find the sum? So you can can you use a calculator to find the sum? Well, here's what you're looking for. So on your calculator, you cannot put in the infinite. When we talked about this in the last section, that you can go to your math button and scroll down to 0 and you'll have the summation notation, but there's no infinity symbol. So instead, you do have a converging series because r is 2/3. So instead you can use 50. So use a large number. Oftentimes I'll even use 100. You can use 50 for infinity. And in this case, if you plug in and put 50 in place here, your calculator, so again you're using the math button on your calculator, scroll down to 0 and you'll see summation, and you have to actually input x equals 1 in for this, put 50 in for the upper bound, put 2/3 in here and raise it to the x. So make sure you put all that in there. So when you do, you should get the sum is approximately equal to 1.999, and then if you use 100 as I suggested for infinity, so do it again, then your sum is going to equal 2. So the bigger the number is, the closer you're getting to 2. So our sum should be 2. And then if you do it algebraically, you're going to use the formula we used above because it's an infinite series. So sum is equal to, and it's converging. Your a sub 1 is 2/3. That's your first term if you plug in 1 up there, divided by 1 minus 2/3. 2/3 is our r. And so you end up with 2/3 divided by 1/3, which equals 2/3 times 3/1, which these cancel, oops, and you get 2. I'll try again, 2, there we go, 2, I'll get it eventually, done. Good luck with your homework.